I got this Richmond, and then today we are talking about how we can solve basic problems in differentiation using the first principle. And then the question is saying that this is the question, and is y is equal to x squared. So we should solve it using the first principle of differentiation. And then to solve this question using the first principle, you need to create your formula, and the formula is the y over the x is equal to the limit, limit as change of x approaches 0, f of x plus change of x minus f of x all over change of x. So this is the formula that we can use to find from first principle the differentiation of the question. So now I'll do that y is equal to x squared. So here it means that the whole of this f will occupy by the function. So the function y is equal to x squared. So we just come and we write the same thing, limit as change of x approaches 0 here. And then here's x squared plus change of x. So you come and write x plus change of x here, all raised to the power 2 because of the square here, minus f of x, and then y is equal to s squared, and then f of x is the same as y, so you write it here, the value of y, which is x squared, like this, and then put it here, all over change of x. So now we need to expand the bracket. So by expanding the bracket, write your limit of the change of x approaches 0, and then we have this. So expanding the bracket, we can write x plus change of x multiplying x plus change of x here. That expansion of the bracket minus x squared all over change of x. Like this. And we move on. So let's expand it. We multiply the first x here in the first bracket by the first x in the second bracket, and you have your limit as change of x approaches 0. So you get x squared, x times x will give you x squared, x times change of x will give you plus x change of x plus another x change of x, and then change of x times change of x gives us plus change of x all square, then minus your x square here all over change of x. Simple like this. So now we can see that there is x square here plus x square here and minus x square here. So definitely this minus x square will cancel this positive x square, and now it will be left with your limit as change of x approaches 0, and then you have x multiplying change of x, another x multiplying, so you get 2x change of x plus change of x square all over change of x here, like this. So we are continuing and have the limit as change of x approaches 0 here, and then we divide the top half of the fraction by the denominator, that's change of x. So 2x change of x over this x means that you're going to get 2x change of x over change of x plus change of x square over change of x, like this. Okay, so change of x will cancel change of x, and then change of x squared divided by change of x will give us just change of x. So this one will cancel this one, have change of x. So have our limits as change of x approaches 0, and that is 2x plus change of x, like this one. Okay, so all that I have to do here is simply I have to state a condition here. As change of x approaches 0, then the whole of this expression 2x plus change of x now becomes 2x plus 0, which is now equal to 2x, like this. So this is how we can find, by using the first principle of differentiation, to differentiate this function. So the next tutorial will take another example, and then we try to see how we can solve complex questions. If you like this video, you can subscribe, share, and like it too. Thank you.